Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at similar figures. So you probably have an understanding of the layman's definition of similar. You probably use the word all the time, but in mathematics it has a very specific definition. So for two shapes to be similar, both of these must be true. So pairs of corresponding angles must be equal and pairs of corresponding sides are in the same proportion. So let's look at these two red shapes here. So they're both rectangles. So what that means, if it's a rectangle, all angles are 90 degrees. So here, each shape has the same angles. This is what we mean by the first condition here. This angle and this angle are corresponding, they're matching up, and they're equal. These two are corresponding, and so on. Basically, the first one is saying the two shapes have the same set of angles. So that one's true for these two. But are pairs of corresponding sides in the same proportion? So again, corresponding here, we mean matching. So we match the longest side of each shape. So 8 and 12. So the scale factor from 8 to 12 is 12 divided by 8, which gives you 1.5. So that means here that the side in the larger shape is 1.5 times the side in the smaller shape. We have to check that that's true for the other sides in the shape. So the scale factor for the largest side in each shape was 1.5. What about the shortest side in each shape? Well, it also turns out that 9 over 6 is also 1.5. So it turns out the second condition is true. For these two shapes, sides are in proportion. Another way of saying that is the scale factor is consistent. The scale factor between these two sides is 1.5. The scale factor between these two sides is 1.5. So because we have pairs of corresponding angles equal and pairs of corresponding sides in the same proportion, these two shapes are similar. It means the same shape, one is just a larger version of the other. If we look at these two blue shapes, however, it turns out that they have sides in the same proportion. So the two longest sides in each shape are 2 and 4. So the scale factor of the longest sides is 4 over 2. And it turns out that that's the same as 3 over 1.5. The sides are in proportion with these two shapes because the longest side is double the longest side and the shortest side is double the shortest side. That's what we mean by in proportion. The scale factor is consistent. Scale factor from here to here is 2. The scale factor from here to here is 2. The sides in this shape are double the sides in this shape. But even though pairs of corresponding sides are equal for these two shapes, they are clearly not similar. See, to be similar, they have to be the same shape. This is a parallelogram, this is a rectangle. Another way to say that more formally is they don't have the same angles. So for this rectangle, it has 4 90-degree angles. Whereas this shape here does not have any right angles. So that's why these two are not similar. Even though sides are in the same proportion, they are not similar because corresponding angles are not equal. These two angles are not equal, these two angles are not equal, and so on. They don't have the same set of angles. So it's important to note, for two shapes to be similar, both of these need to be true, not just one of them. All right, let's now look at using similar figures to find unknown sides. So we've talked a lot about scale factor. We were introduced to it in the previous lesson. So when we're looking at finding unknown sides, we're going to calculate the scale factor as the side in the larger shape divided by the corresponding side in the smaller shape. We then use the scale factor to find unknown sides. So I always want you to do largest shape divided by smaller shape because then it's really easy to find unknown sides. You always multiply to find a side in the larger shape and divide to find a side in the smaller shape. All right, so we're told that these two shapes here are similar. That means they'll have the same angles. It means that sides are in proportion. So we can use that to find the value of x and y. So what we have to do first is find the scale factor. So we need to find two sides that are corresponding, two sides that are matching. So sometimes it can be difficult to match up sides to find which side in this shape corresponds to which side in this. So you may be helped by finding which angles correspond with each other. For example, this is the largest angle in the larger shape. So it's going to correspond to the largest angle in this shape. Turns out the largest angle in this shape is here. So these two angles correspond. Similarly, this angle here looks like the smallest angle in the larger shape. So it's going to correspond to the smallest angle in this shape here. So that helps us. Why does it help us? Well, see that 12.8 is touching these two angles. It corresponds with the side that's touching those two angles. So 12.8 and 8 are corresponding. That's really helpful because it allows us to figure out the scale factor is the side in the larger shape divided by corresponding side in the smaller shape. So if you put that on your calculator, you get 1.6. That means that sides in this shape are 1.6 times as long as their corresponding sides in this shape. So let's go through and find what x and y are. So x here, you can see, is opposite to these two angles here. So it corresponds to the side here that is opposite those two same angles. X and 7.5 are corresponding sides. So when you want to find a side in the larger shape, you multiply by the scale factor. So we take the corresponding side, we multiply by the scale factor. And so putting that in your calculator, you get x equals 12. So let's now look at y. So y is the one that meets this longest side at the largest angle. So y actually corresponds to 8 here. So we're finding a side in the smaller shape, we actually divide. So we take the corresponding side and we divide by the scale factor. So this time we get y equals 5. All right, let's look at a few harder questions. So I'm telling you that these two triangles and these two triangles are similar, and we're going to use this to find the value of x. So these ones are a little tougher. This one's tougher because we have two x's there. We can't find the scale factor easily here. What we do know, however, is that if these two shapes are similar, sides are in proportion. So what that means is largest side in the larger shape and its corresponding side, that's going to be the same as the shortest side and its corresponding side. So 25 over x, largest side divide largest side, equals smallest side divide smallest side. So we can solve this equation. What we do is cross multiply. 25 times 16, x times x. So 25 times 16 is 400, x times x is x squared, and then we just square root. So x is equal to 20, because 25 over 20 is 1.25, 20 over 16 is 1.25. All right, let's look at these here. So we have similar triangles here. It turns out we can find the scale factor here, but the scale factor isn't 10 over 8. We have the shorter side in the smaller triangle is 10, but its corresponding side in the larger triangle is 10 plus 8, which is 18. So the scale factor here is actually 18 over 10, which is 1.8. So how are we going to use that to figure out x? Well, the side in the smaller triangle is x, and the side in the larger triangle is x plus 5. So what the scale factor means is that a side in the larger shape is 1.8 times the corresponding side in the smaller shape. So lucky we did a bit on equations. To solve an equation with pronumeral on both sides, you subtract the one with the lowest coefficient. I'm going to subtract x, or subtract 1x from both sides. I'm left with 5 equals 0.8x, because 1.8 minus 1 gives 0.8, and x is just going to be 5 divided by 0.8. And then you can use your calculator for that. You get x equals 6.25. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.